All right, so there's going to be a lot going on in this video because I'm going to actually introduce you to the unit circle now. So, I guess maybe. Here we go. All right, wow, that that took a turn there. Let's get this guy to move down here. All right, cool. So what I'm going to show you now is called the unit circle. All right, and the way that the unit circle works, I wish I could make this bigger, but I guess I'm stuck with what's ever going on here. Oh, there we go. Okay, so here's what the unit circle is. All right, the unit circle is obviously a circle. It is centered at the origin of a coordinate plane, and I'll make sure that once I'm done saying that, I'll make that true. So its center is 0, 0 on the coordinate plane. So there we go. And so the center, I'll write that up here. The center of the unit circle is 0, 0 on a coordinate plane, and its radius has a length of 1 unit. So that's why we call it the unit circle, okay? Like I said, most of the kids in class are going to have to memorize this, and I'm just going to simply let you use a unit circle. So you don't have to memorize any of this, but I need to show you how to use it, okay? So the first thing is this. If you have a radius of 1, and you start at 0, 0, and I walk to the right 1, and then I don't go up or down at all, then this ordered pair right here on the end of that circle is 0. I'm sorry, that's a lie. It's 1, 0. Because this distance right here is 1, and then I didn't go up or down at all. And remember, ordered pairs always go x, y. All right? So I'm going to do that. This is also 0 degrees, right? So if my initial side and my terminal side of my angle are at the same place, that's 0 degrees. Now, if we go straight up and down to this guy up here, okay, he has an ordered pair of, now I didn't go left or right, so that would be 0, but I went straight up to the edge of the circle, so that would be 1. And this guy up here would be 90 degrees, because that's a right angle. If I continue my way around the circle, by the way, these are called quadrant angles because they're on the axes. This guy right here, if you think about this angle, right, that's 180 degrees. And I went left 1, because that's the radius of the unit circle, and I didn't go up or down at all. So that ordered pair right there would be -1, 0. If I go another 90 degrees and I go straight down and I put an ordered pair on the circle here, that would be 270 degrees. And this ordered pair, well, I didn't go left or right at all, so that would be 0. And I went straight down 1 unit, so that ordered pair would be 0, -1. And if I keep going around the unit circle, 0 is the same thing as 360 degrees, because if I go all the way around the circle like that, that's 360 degrees. Now, what I'm going to do next is I'm going to show you the most important angles on the unit circle, okay? And the first one is a 45-degree angle, which is going to cut this quadrant right in half, okay? So this is a 45-degree angle right here, 45 degrees. And I'm going to erase that because it's going to get in our way. Well, no, I'll leave it actually. So I want to figure out the ordered pair right here. Well, to figure out that ordered pair, I'm going to drop down in altitude, and I'm going to make a right angle. If I know, and actually let me erase this because it looks like a 1. I actually know that this hypotenuse is 1 because the hypotenuse is the radius of the unit circle. Well, from before, we just did 45, 45, 90s in the previous video. So if I go down here and we do a 45, 45, 90 together, I'm going to make the hypotenuse 1. And then if you remember from the previous video, if you want to go from the hypotenuse to the leg, you divide by the square root of 2. So if I do 1 over the square root of 2 and I rationalize it, then I get that each leg is the square root of 2 over 2. So I'll write that here. And then I'll go back up to the circle. And if this is root 2 over 2, and this is root 2 over 2, then this ordered pair has an x coordinate of root 2 over 2 and a y coordinate of root 2 over 2. Now, what's neat about that is I can continue my way around the circle, and these are all going to be 45 degree angles, but they're in the different quadrants, so they have different measures. So, for example, if I do 90 plus 45, then this angle right here would be 135 degrees. And it would have an ordered pair of, well, if I go left root 2 over 2, then this would be negative root 2 over 2. But I'm still going up the same amount, so this would be positive root 2 over 2. Now I can continue to do that. If I go 45 degrees past 180, that would be 225 degrees. And this ordered pair, since I'm going left and down, it would be negative root 2 over 2, negative root 2 over 2. And then lastly, if I go 45 degrees past 270, this would be 315 degrees. I'm going right, so I would have positive root 2 over 2 again, and then negative root 2 over 2 for my y value. And then what I'm going to do is I'm going to kind of squeeze 45 degrees into here. So what I just did was I used a special right triangle of 45 degrees to work my way around the unit circle and create these ordered pairs. What I'll show you once I've created all the ordered pairs is how to use the ordered pairs, but for right now, I'm just going to show you how to create them all. Okay, so I showed you how we got the points on the unit circle for the angles that are 45 degrees from the x-axis. I should also mention that the distance, or the angular distance to be more precise, is that, so this distance from this ray to the x-axis, that being 45 degrees is called a reference angle. This angle here is also 45 degrees from the x-axis. This angle 225 is also 45 degrees from the x-axis. And lastly, 315 degrees is 45 degrees from the x-axis. So these angles, 45, 135, 225, and 315, all have what are called the same reference angle. And a reference angle is an acute angle, so it's between 0 and 90. It's an acute angle, and in our class, it's going to measure the distance from the terminal side of the angle, so the terminal ray, from the terminal side of the angle to the x-axis. And make sure you're always measuring with respect to the x-axis. And that'll come into play a little bit later. So the second thing I'm going to do here is I'm going to show you how we use 30, 60, 90 right triangles to get more points on the unit circle. So I'm going to start by drawing a circle again. And let me actually move this down and make it way smaller, I think. There we go. Oh, it's turning it into an ellipse now. Let me just try that again. Okay, so let me shapes, and then there we go. That'll be good enough. And then let's get some straight lines on here. So that guy, this guy, and he is not in the right place. So let's quickly move him over. And that looks pretty good. Okay, so what I'm going to do now is I'm going to draw another angle in standard position. And this time the angle is going to be 30 degrees from the x-axis. All right, so this is going to be 30 degrees right here. And sorry, that's really hard to see. So let's try again. 30, there we go, degrees. If I drop down an altitude this time, and like I did earlier, I'm going to let the hypotenuse be 1 because the radius of the unit circle is 1. If I kind of go down here, or I guess over because I'm out of room, and I draw a 30, 60, 90 right triangle, we can find the sides like I did earlier with the 45, 45, 90. So if this is 30 degrees, and this is 60 degrees, and this is 90, and we let the hypotenuse be 1 because, again, the radius of the unit circle is 1. Remember to go from the hypotenuse to the short leg, we divide by 2. So this side would be 1/2. And then to go from the short, sorry, I went the wrong way. To go from the hypotenuse to the short leg, we divide by 2. So that would be 1/2. And then to go from the short leg to the long leg, we multiply by √3. So if you take 1/2 times √3, we would get √3 over 2. So what I'm going to do here is just bring this information over to the unit circle, and I'll put √3 over 2 here and 1/2 here. And what that means is this ordered pair would be √3 over 2, comma 1/2. And again, this is 30 degrees. Now, if I go over to the second quadrant and I draw an angle that is 30 degrees off of the x-axis, so the x-axis is 180, and if you do 180 minus 30, you get 150 degrees, okay? And if you look, like if I tried to mimic what I did over there, these would be equal, right? So this distance here, again, is √3 over 2, and this distance here is 1/2. So this ordered pair would be, now we're going left, so it would be negative √3 over 2, and the y coordinate, we're going up, so it would still be positive 1/2. If we do the same thing in the third quadrant, so I'm going to be 180 degrees past 180, so that means that this angle would be 180 plus 30, which is 210 degrees. And to get to this ordered pair, I'd be going left and down, but the same distance. So negative √3 over 2 and negative 1/2 this time because I'm going down. And then lastly, this angle over here, that didn't do what I wanted it to do, so let me get rid of that, get it out of the way. We're going to go 30 degrees off of the x-axis again, but we're going to go into the fourth quadrant. So if I'm 30 degrees from 360, so I'm short, this would be 330 degrees because all of these angles have a reference angle of 30 degrees. So they are all 30 degrees from the x-axis. And remember, the x-axis over here, right, this is 180. So I went 30 past it and got 210. But now this will be 360 if I went the whole way around like this. But I'm stopping 30 degrees short, so that's where I got 330. But again, this distance we figured out is √3 over 2. And I'm going right again, so it would be positive √3 over 2. But I'm going down, and so that would be negative 1/2. So all of the angles that are 30 degrees from the x-axis have some combination of an x-coordinate of √3 over 2 and a y-coordinate of 1/2. Now lastly, and I'm only going to do this once so that we don't have to go through the whole thing again, if you draw a 60-degree angle here, so we'll try to do our best, and then and I'm going to erase some of this just to kind of get it out of the way. So let's see if I can get him out of the way. There we go. Normally what happens is I erase everything on Earth. So I'm going to draw a 60-degree angle here, and I'm going to drop down an altitude to make a right triangle. And this is going to be 60 degrees. Well, if you think about it, and I'll draw that triangle over here, it's still a 30, 60, 90. It's just oriented a little differently. So this is going to be 60 this time, and this would be 30. So again, if the hypotenuse is 1, then this side is 1/2, and this side is √3/2. So same numbers, just in different places. Well, what that means is this ordered pair here would be the x coordinate is 1/2, so that's flipped from this one. And then the y coordinate would be √3/2. And again, that would happen all the way around the unit circle. So just real quickly, this angle is going to have, this would be 120. So this is 120 degrees because it's 60 degrees from the x-axis. And then this angle would be 180 plus 60. So that would be 240. And then this angle here would be 60 degrees from 360. So short, this would be 300 degrees. They're all going to have this ordered pair with the correct sides. Okay, so what I'm going to do next is, instead of seriously going through every single point, I'm going to bring up a completed unit circle for you and just show you briefly how to use it. Hopefully this adds. So I'm going to pause the video so that you don't have to wait for this part, and I will upload a completed unit circle and I'll show you how to use it. Here's a completed unit circle, and it's actually color-coded by the reference angles. So you'll see all of the angles that are 30 degrees from the x-axis are in orange. All of the angles that are 45 degrees from the x-axis are in green. And all of the angles that are 60 degrees from the x-axis are in yellow. And all of the ordered pairs are with them. I'm not sure why they used brackets. I mean, obviously those should be parentheses, but I like this color-coded one. That's why I picked it. Lastly, you'll see that all of the angles are also measured in radians, and the unit circle that I give you to use will be the same way. I'm just going to show you how to use it now. All right, so check this out. And this is just a little bit of memorization, but it should also be pretty intuitive just using some SOHCAHTOA. All right, so I'm just going to put theta here because what that means is that it works for any angle on the unit circle. It's a right triangle. And then we're going to have an ordered pair here every single time. So that's these ordered pairs right here. And ordered pairs are written in terms of x and then y. Okay. This distance is x and this distance is y because this is the x-axis and this is the y-axis. And then every single time the hypotenuse on the unit circle is 1. So if we just do some SOHCAHTOA here, here's what we can see. We know that the sine of an angle is equal to the opposite side, so in this case that would be y, over the hypotenuse, which is 1. And we know that y divided by 1 is just y. So what we've just shown here is that the sine of any angle on the unit circle is just equal to whatever its y coordinate is. So what that means is if I ask you what is the sine of 30 degrees, so if I said what's the sine of 30 degrees, all you have to do is look at your unit circle, go to 30 degrees, and read me the y coordinate. So the sine of 30 degrees would just be 1/2. If you want the cosine of an angle on a unit circle, well, that's the adjacent side over the hypotenuse, so that's just x. So the cosine of an angle is equal to its x coordinate. So for example, if I want the cosine of 30 degrees, I just go to the unit circle and I find 30 degrees and I just look at its x coordinate. And its x coordinate would be √3/2. So the other trig functions that we want to take a look at, the other 4, right? So we started with sine and cosine, but we still have to show you how to do tangent and then all of the reciprocals. So let's take a look at the tangent of an angle. So if you want the tangent of an angle, we know that's going to be the opposite side, which in this case is y, divided by the adjacent side, which in this case is x. So to get the tangent of an angle on the unit circle, you would take the y coordinate, So let's go ahead. I'll scroll down and I'll do the tangent of 30, right? So if I want to do the tangent of 30 degrees, I would take the y coordinate at 30, which is 1/2, and I would divide that by the x coordinate at 30, which is √3/2. And then we have to actually do the division. And to divide fractions, you multiply by the reciprocal. So it would be the reciprocal of the denominator. So you would take 1/2 and multiply that by the reciprocal of the denominator. So 2/√3. You can cross cancel the 2's, and you would get 1/√3. And then you would rationalize this by multiplying the top and bottom by the square root of 3. So you multiply the bottom by √3, and then you multiply the top by √3, and you get √3 over √3 times √3 is √9, so that would be 3. So the tangent of 30 degrees is √3/3. I'm going to go ahead and write that down here so you can see it all, so we can do the reciprocals. So we know that the sine of 30 is equal to 1/2, because that's the y coordinate on the unit circle. We know that the cosine of 30 degrees is √3/2, and that's because that's the x coordinate of that angle on the unit circle. And we know that the tangent of 30 degrees is √3/3, and that's because we did the y coordinate divided by the x coordinate. To get the reciprocals, it's actually really easy. You just flip all of these answers. So if I want the cosecant of 30, I just take the reciprocal of 1/2, which is 2. If I want the secant of 30 degrees, I take the reciprocal of √3/2, and I get 2/√3, and rationalize it. So you get 2√3/3. And then for the cotangent of 30 degrees, you're going to flip 3/√3 and then rationalize it. So that's 3√3/3, and then simplify to √3. And so that's all you do for every single angle that's on the unit circle. And remember, I told you, you can go ahead and use a unit circle, so you don't have to memorize it. So what I'll do is I'll do a couple of more examples with you on this. We'll keep doing this video here. But I'm going to just add a page here and just write down some examples, and we'll go ahead and take a look at those. Okay. All right, so let's see here. Give me 1 second. I think we're good here. Okay, and then we'll go ahead and paste this here. So, all right. I'm just going to go ahead and pick some practice problems and show you how to do them. So let's just go ahead. We'll start out with some easy ones. Let's do the sine of 240 degrees. So all we have to do is remember that if your coordinates are x, y, that's cosine theta, sine theta. Okay? All right, so the sine of 240 would be the y coordinate at 240. So here's 240, here's the y coordinate, and so the sine of 240 is negative √3/2. So that's the sine of 240. If we want to say, let's do the tangent, and I'm going to actually do one of these quadrant angles so that you can see what happens. So let's do the tangent of 180 degrees. Well, if you remember, tangent is the y coordinate divided by the x coordinate. So here's 180, here's the ordered pair. So the y coordinate is 0, and the x coordinate is -1. So 0 divided by -1 is 0. So the tangent of 180 is 0. While we're at it, let's go ahead and do the cotangent of 180, because I want to show you what happens. So if we were to flip this fraction right here, because that's the reciprocal of tangent, we would get -1 over 0. And if you try to divide by 0, that's actually undefined. So the cotangent of 180 degrees is actually undefined. So you can write the word undefined, or you can use this symbol, which is the empty set or null set, just meaning no solution. So most people just use the circle with the line through it. We'll just kind of pick another one. Let's do the secant of 300 degrees. So the secant is the reciprocal of cosine. So the way I would do this is I would write, okay, let's look at the cosine of 300 degrees. And the cosine of 300 degrees is the x-coordinate, so that's 1/2. And so then the secant of 300 degrees is just the reciprocal of 1/2, which is 2. And let's see, I'll do one more with you. Let's go ahead and do the, let's see what we haven't done. We'll do cosecant. Let's do the cosecant of 200 and actually, yeah, let's do 225 degrees. So I know the cosecant is the reciprocal of sine. So I'm going to look up the sine of 225 degrees. So here's 225. Remember that the sine is the y-coordinate. So the sine of 225 is -√2 over 2. And so for the cosecant, I'm going to take the reciprocal. So that would be -2 over the square root of 2. And I'm going to go ahead and rationalize that by multiplying top and bottom by the square root of 2. So that would be -2√2 over 2. And if I simplify that, that would actually just simplify to negative square root of 2.